Today we're going to be talking about triangles and midsegments and medians. Let's start with a midsegment. What is a midsegment? A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. Now every triangle has three midsegments. So here's an example. We have triangle ABC, and you can see here that the midpoints are at M, P, and N. And so any of those segments connecting those midpoints are what we call midsegments. So MP is a midsegment because it connects M and P, and those are both midpoints of those two sides. MN is a midsegment, and NP is also a midsegment. So there is a theorem that goes along with midsegments, and this theorem says that the segment connecting the midpoints of two sides of a triangle, so the midsegment, is parallel to the third side and is half as long as that side. So here's an example. So DE here is a midsegment that connects the midpoints of AB and BC. And this theorem tells us that DE is parallel to the third side, AC, and it is also half the length of AC. So DE parallel to AC, and DE is equal to 1/2 of AC. All right, take a look at example 1. Triangles are used for strength in roof trusses. In the diagram, segments UV and VW are midsegments of triangle RST. Find UV and RS. Okay, so to start, we're going to find UV. Now UV is a midsegment, and we know it is parallel to that third side, RT, and it is also half the measure of RT. So since we're told RT is equal to 90 inches, that must mean that UV is half of 90, which means it's equal to 45 inches. Now let's find RS. RS is a side of the triangle, and we know that the midsegment VW is parallel to it, and we also know that VW is also half the measure of RS. That means RS is twice the measure of VW. Now, if we know that VW is equal to 57, that means that RS is going to equal 2 times 57, which is equal to 114 inches. Next, we're going to talk about the median. So the midsegment is the segment that connects midpoints of a triangle together. Now the median is a segment that goes from a vertex to the midpoint of the opposite side. So it's not connecting midpoints together, it's connecting one midpoint to the vertex. So here's an example. In this triangle here, you can see the midpoints of each side are connected to the vertex that it's opposite, that it's across from. And in every triangle, there are 3 medians, and they are concurrent. Now what we mean by concurrent is that when you draw all 3 of the medians together in the same triangle, they are going to intersect at one point. All 3 of them are going to intersect at that one point. Now that point of concurrency is what we call the centroid, and it's always going to be inside of the triangle. Now we have a theorem that goes along with medians of a triangle, and this says that the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Let's see what that looks like. Here's a triangle ABC, and we see that the medians are drawn here, and they intersect at point P. What this theorem says is, for example, if you look at AE, that entire segment there, this says that point P is 2/3 of the way from the vertex to the midpoint of the opposite side. So AP is equal to 2/3 of AE. And then PE must then be 1/3 of AE. And that's true for all 3 of those. So AP is equal to 2/3 of AE, BP is equal to 2/3 of BF, and CP is 2/3 of CD. So it's always the portion of the median that goes from the vertex to the point of concurrency. That's always going to be 2/3 of the entire median. Take a look at example 2. In triangle RST, Q is the centroid and SQ is equal to 8. Find QW and SW. Let's start by finding SW. Now, based on the theorem, we can say that SQ is going to be 2/3 of SW. So we'll write that down. Now we're told SQ is equal to 8. Substitute, and then we'll go ahead and multiply both sides by 3 and divide by 2, and that gives us that SW must be equal to 12. Now, if you know that SW is equal to 12, now we can find the length of QW. So since SQ is 8 and SW is 12, all we need to do is say, well, QW is SW minus SQ, which would be 12, minus 8, which gives us 4. So that means QW is equal to 4. So for this problem here, QW equals 4 and SW equals 12. Now in this example, it says the vertices of triangle FGH are 2, 5, 4, 9, and 6, 1. Which ordered pair gives the coordinates of the centroid P of triangle FGH? Let's start by sketching the triangle FGH. All right, so 2, 5, 4, 9, and 6, 1. Connect those. So there's our triangle. And then we can use the midpoint formula to find the midpoint of FH. So let's say, now in order to determine where the centroid P is, we're going to need to draw out one of the medians. So let's say, for example, let's find the midpoint of FH, and we'll call that K, and then we'll go ahead and sketch that median from G to K. So the midpoint would be 2 plus 6 over 2, and then 5 plus 1 over 2, that's just using the midpoint formula, and that gives us K is equal to 4, 3. Let's go and put that on our graph. We draw the line going from K to G, and now we've drawn one of the medians. Now, where do we go from here? We're trying to find the centroid P. Now remember, the centroid is going to mark 2/3 of the distance from the vertex to the other side. So if we can find the distance from G to K, and then we can find 2/3 of it, we'll be able to determine where exactly the centroid is. So the distance from G to K is 6 units. You can see that on the graph there. And the centroid must then be 2/3 of 6, which is equal to 4. So starting from G, if I count down 4 units, then that tells us that this is going to be at 4, 5. So our answer is going to be at 4, 5.